Hey everybody. All right, so this whole week we've been doing, heat calculation practice problems, and so we've done, energy of a phase change, energy to increase the temperature of something, so using specific heat capacity, and then talking about the lab technique of calorimetry. And so we'll do our lab when we get back from break, but I want to do one more practice problem with you, and that is a calorimetry problem that was on the 2017 free response AP exam. So this was question number 5. So this is a 4-point question, and it had 3 parts to it. So one of the parts was worth 2 points. And so you have to, when you see this question, there's a good amount of reading involved in it, and you want to make sure you read everything. But the actual calculation part of it and stuff should come pretty quickly. So you want to think that the maximum amount of time you would want to spend on this question is about 8 to 10 minutes max. Okay. So I want you to see a type of calorimetry problem that you might see on the AP exam. This was a calorimetry question, and it was dedicated a full, one out of the 7 free response questions. This was dedicated to calorimetry. Now it was really only 4 points out of 46 because it was one of the last 4 questions. But calorimetry and heat exchange is a big part of the exam. So you can always expect a couple multiple choice questions that might have to do with heat change and calorimetry. And then here's an example on the 2017 test where you had a full free response question on it. So let's go ahead and look into that. All right. So again, this was the 2017 AP chemistry exam, and this was question number 5. All right. So we get a combustion reaction of what they say is 2-propanol. Now that 2 doesn't mean anything. That 2 has nothing to do with that coefficient 2 there. That's just part of the name. It's just telling you the OH group, the alcohol group, is on carbon 2. So if you remember our kind of organic nomenclature stuff, that's all that is. So it's just propanol. So that's the formula for propanol, which combusts in oxygen according to the equation above. Okay. The student heats a sample of water by burning some of the propanol that is in an alcohol burner. All right. So let's look at the setup. You got propanol here, and it's burning via this wick, and the heat being produced from that combustion reaction is going to the water in this beaker. So notice we're not mixing the propanol with the water. It's just we have a combustion reaction going on right here, right at the flame. That's the combustion reaction, and we're assuming that the heat produced from that combustion reaction is being absorbed by the water here. Okay. And so what they did was, I guess they said the mass of the propanol that underwent combustion is determined by weighing this before and after. So you can measure, so you weigh the container before, you weigh it after the combustion reaction, and the difference would be the mass of the propanol that underwent combustion, right? Okay. So let's understand another thing too. This is the water, this right here is the water produced by the combustion reaction. That has nothing to do with this setup, right? The water in here is not the water produced by the combustion reaction. Okay, so it's just the combustion reaction is happening here. It's producing CO2, it's producing water vapor. Where is that going? That's going away into the air. Okay, great. We don't care about that. But all of the heat that's generated from that combustion reaction is to be assumed, and I'll show you where they tell you that, is to be assumed to be absorbed by the water. So we should expect, like, what's going to happen is the combustion of the propanol is going to release energy. That energy is going to be absorbed by these water molecules, and the water molecules are going to increase in temperature. Okay? All right. So here's the data from the experiment. so the mass of the propanol that underwent combustion. So they did the final minus initial. They did the final mass minus the initial mass for us. So they gave us that. So 0.55 grams of propanol underwent combustion. They give us the mass of the water in this beaker, 125 grams. A lot of times they might give you the volume and tell you the density is 1 gram per milliliter. So the volume in milliliters is the mass in grams. But in this case, they gave us the grams. So that's nice. They gave us the initial temperature of the water and the final temperature after the combustion reaction. And they gave us the heat capacity of water. Okay. So if you remember from our practice problems last class, when we mixed a solid in water and it dissolved, or we mixed two solutions together and they mixed with each other, the total mass we plugged in to the Q equals MCAT calculation was the sum of the two masses combined. But understand, we're not doing that here. We don't have to add this mass to this mass because the propanol and the water that it was heating up never mix. We burn the propanol and the heat goes from here to the water, but the propanol and the water don't mix. So the mass we're going to use in our Q equals MCAT is just this, okay, 125. Don't do 125.55, okay? I know that's going to be a big mistake that a lot of kids would have made in this question. All right, so that's the whole scenario. That's the whole scenario, okay? And then these are the three questions we need to answer. So it says calculate the magnitude of heat energy in kilojoules absorbed by the water, okay? And it says assume that the energy released from the combustion is completely transferred to the water. So that means none of the heat, as this burns, none of the heat escapes to the air, none of the heat gets absorbed by the beaker, it only gets absorbed by the water in the beaker. Okay, so that's a big assumption, but most of the time that's the kind of assumption we're told to make, okay? And so we know the initial temperature of the water, the final temperature of the water, we know the heat capacity of the water, and we know the mass of the water. This is just a Q equals MCAT. But we have to understand that when we solve this, right, so what's going to be delta T? It's going to be 51.1 minus 22.0, okay? But when we solve for this, all right, when we solve for this, it's going to be in joules because of the heat capacity given to us was joules per gram degree Celsius. So we're going to do this times the delta T times that, and then what we have to do is divide by 1,000, okay? So let's go to the scoring guide and see how AP graded it, okay? So hey, here's Q equals MCAT, this times that. Okay, so when we subtract, we end up with 3 sig figs there. That has 3 sig figs, this has 5 sig figs, but since this has 3 and then this has 3, we should limit our answer to 3 sig figs. And it comes out to be positive 15,200 joules. We divide by 1,000, that's 15.2 kilojoules. All right, and so boom, you got 1 point. And you wouldn't have gotten the point if you just reported this, all right? They specifically told you to get it in kilojoules, and so you'd have to know to make that conversion. All right. All right, so let's go back up to question B. Okay, based on the experimental data, if 1 mole of propanol undergoes combustion, how much heat in kilojoules is released? Report your answer with the correct number of significant figures. Okay, so here's where I'll argue that because it's asking how much heat is released, you don't need the negative sign, but it would be okay if you had the negative sign. But here's the deal. It's asking you to report the number in sig with correct sig figs. So let's understand what we're gonna do. We got this. Part A, we answered 15.2 kilojoules. And all we have to do is divide by moles of propanol. If we take that 15.2 kilojoules from part A and divide it by the moles of propanol that underwent combustion, that would give us energy per mole of propanol, and that would be our answer. But notice that the mass we were given for propanol only has 2 significant figures. So when we calculate moles of propanol by taking the mass of the propanol and divide by the molar mass of propanol, that means our moles are only going to have 2 sig digs. our answer for part A has 3 sig digs, but we're going to divide it by moles, which can only have 2 sig digs based on that measurement there. So our final answer in part B should only have 2 sig figs. Okay? Now, should it have a negative sign? Not necessarily, because it says is released. But if they were trying, let's say in part B, they just wanted us to figure out the delta H of this reaction, a couple things we'd have to do. We'd have to know that we have to flip the sign, so the delta H of this reaction is negative. We should know that because it's a combustion reaction. But remember, this was heat released, this was water heating up based on the heat released by the reaction, so the reaction was exothermic. Okay. Another thing is, if we got energy per mole of propanol in part B, but we wanted the delta H for this reaction, we'd have to double it because this shows 2 moles of propanol undergoing combustion. But again, that's not what was asked here. It was just, hey, what's the energy per mole of propanol? And the key here is significant figures. So it's not a difficult calculation. It's just we got to have our correct sig digs, and we'd have to see, oh, the mass of propanol they gave us only has 2 significant figures. So that means when I calculate moles of propanol, that can only have 2. So when I take the energy that I calculated in part A, that has 3 sig figs, and I divide it by the 2 sig figs for the moles of propanol, that's going to mean I need 2 sig figs for my final answer. So let's go to part B. Let's see how they did that. Okay. All right. So okay. I don't know if I would have done it this way, but what they did was they took I guess the 15.2 kilojoules and divided by the grams of propanol, and that would give you kilojoules per gram. And I would just get, and then I would just divide by moles of propanol to get kilojoules per mole. But what they did was say, okay, if 1 mole of propanol, they just used the ratio. If 1 mole of propanol burns, let's convert moles to grams. And they converted moles to grams, and then they used this ratio to convert from grams to energy. Okay. The way I would be thinking to do it is take 0.55 grams of propanol, divide by the molar mass of propanol. So I would have done 0.55 divided by 60.09. That would give me moles of propanol. And then I would have taken the 15.2 and divided by the moles. And it would come out to be the same number. But anyway, so that gives you this much kilojoules, 1,661 kilojoules. But we have to report it to 2 sig digs. So you can use scientific notation. But if you just put 1700, 1700, that would have been fine too, just without the decimal. That would be 2 sig figs as well. So 1.7 times 10 to the third, or 1700 kilojoules would be your final answer. And notice you got 1 point earned for the correct amount of heat released and 1 point earned for reporting the answer with significant figures. So even if you didn't get the right sig figs, if you got this answer here, you would still get that point. But then they gave you another point for making sure you rounded as sig figs. And notice they said it in the question. And they're anytime they're gonna stick you on significant figures, they're gonna tell you in the question to make sure you use the right number of significant figures, right? All right, so that's 3 points, and we got 1 more point to earn. And so let's look at the last question. It says a second student performs the experiment using the same mass of water at the same initial temperature. So they have 125 grams of water in the beaker, and it's starting at 22 degrees Celsius. However, the student uses an alcohol burner containing propanol that has some water in it. So in this container, we have propanol and some water, not just propanol. Okay. The difference in the mass of the alcohol burner before and after the combustion in the experiment is same this. So the same mass of what was in here undergoes combustion, but remember, it's not all propanol now, some of it's water, okay? Would the final temperature of the water in the beaker heated by the alcohol burner in the experiment be greater than, less than, or equal to the final temperature of the water? So let's understand, because this was contaminated with water and not just pure propanol, and you lost the same mass, that 0.55 grams that you lost in this second experiment was not all propanol. Some of it was water, okay? So that means you wouldn't have produced as much heat because not all of this was propanol, so you have less number of moles of propanol that burn. So if you have less moles of propanol that burn in the second experiment, you would have less heat released. So that means less heat absorbed by the water, and so the final temperature of the water would be less than this, right? So the answer would be less than, okay? And to justify, it's because not all of this 0.55 grams was propanol. Some of it was water, and so not as much heat was released, okay? So some kind of explanation leading to that. So let's see what they said on the scoring guide. Okay. So the final temperature measured by the second student would be less than that measured by the first student. So you don't have to write that full sentence. You could say less than, and then now justify. So if you said less than, you are almost there, but you have to have the right justification. So notice, if you didn't have the right justification, you wouldn't get the point, even if you said less than. Sometimes it's 1 point for saying less than, and then 1 point for the correct explanation, but not in this case. So it's less than, but why? It says the actual mass of propanol combusted will be less than 0.55. There you go. What do we say? Yeah, all right. Or combustion of the contaminated sample will also require vaporization of water in the sample. Okay, so it's kind of saying the same thing. So it just means this is not the mass of propanol that combusted. It's going to be less than that because some of that mass would belong to the water that you lost as well. And so you have less moles of propanol undergoing combustion, and that would produce less energy. So that means the water in the beaker would absorb less energy, and it wouldn't heat up to as high of a temperature, right? Okay. So pretty straightforward question, but you gotta put yourself in the shoes of the AP chemistry test taker. Question 5. You're kind of seeing the light at the end of the tunnel. You got 2 more questions to go after this one. You might be running low on time, and you might skip through. You might miss a detail. Like here, you might just say, okay, yep, I know I can calculate the magnitude of heat. You're thinking Q equals MCAT, but if you missed out that it has to be in kilojoules, boom, you're not going to get that point. Here, if you miss out that they wanted it in significant figures, then you might get the point for the correct calculation, but then you wouldn't get the point for the sig figs. And then here, if you just, don't have a proper explanation, then you're not going to get any points, even though you knew it was less than. If you don't have a good explanation, you're not going to get that point, right? So just, little things here. And so again, it's only worth 4 points, and that's the max you can get for this question. You can answer it perfectly, but it's only 4. It's only 4 points, and you're trying to get the most you can out of 46 total points, okay? So anyway, that's just, I just wanted to show you the types of questions that show up on the actual AP exam. Show you that I'm not, making stuff up or anything like that. So hopefully you are feeling confident that you could answer that question, and feeling good about things. Okay. But anyway, I hope you have a good winter break, and when we get back, we'll do our calorimetry lab, and then we will kind of review for the test, and we'll start unit 4 and be moving right along. Okay, so enjoy your break, get some R&R, and see you in the new year.